Okay, so this is a video about Newton's third law pairs. Okay, so Newton's third law pairs. So how do you know if something is a Newton's third law pair, right? So in general, if somebody does something, right? Let's say A and B, right? This looks like a witch, huh? If A pushes B, B pushes A. Has to be, okay? Why? Just is. It just is, okay? Two cars crash into each other. Big car, little car, crash into each other, right? Big car hits little car hits big car. Same force. This is a pair, all right? Now, the little car is going to get more damaged from it. We're going to talk about that later, okay? But the forces are equal. They're being hit with the same force. Okay? So in a force diagram, so let's look back at our good friend person pushing box, because we don't want to do anything else besides that. Okay, so you have the person pushing the box, all right? So if there are two objects and they are interacting, right? We label this in our interaction diagram, PB, person box. Every time you label an interaction in your interaction diagram, that's a pair, right? So person floor, that's a pair. Box floor, that's a pair. Okay? Person earth, that's a pair. Box earth, that's a pair. All right? So let's take a look at the person and the box. All right, so we have the person and the box. All right. So on the box, he has a weight, force of gravity, on the box from the earth. The floor is pushing up, box and floor. Okay. Now, this is what a lot of people think. They think that this is a pair. All right. So to be a pair, the forces have to be equal. They have to be in opposite direction. Why does this pen not work? Because it's Friday night at 9 o'clock. All right. Equal, they have to be in opposite direction, and they have to have a feeler and a dealer. Okay? Only two objects can be involved in the interaction. Okay? Only two objects can be around in this interaction. All right? And they have to be the same force type. Okay, all of these are requirements for it to be a Newton's third law pair. So here I have a feeler and a dealer, or a dealer, or a feeler dealer, right? These are my two guys. Person, box are my two guys. This interaction here is creating both the feeler and the dealer, okay? So this is not a pair, okay? Although it is equal, it is opposite, right? Because these forces are balanced. So I have that. We have that. Do they have the same feeler dealer but swapped? So I have BE and BF, all right? Is that a feeler dealer swap? No, because what do I have? Three objects. I have box, floor, and earth. That's three things involved. So this is not a pair. Okay? Same force type, normal gravity. No, that's not the same force type. This is not a pair. All right, so let's keep looking. Okay, so we see that the person pushes the box and BP, okay? So that's the normal force on the box from the person. All right, and we know we're gonna have to have some friction, box, floor, okay, because this has to be balanced. A little bit bigger. All right, because the box is, let's say, not moving, whatever, I would have to tell you. Okay, so let's look at the person now. The person has his own weight, force of gravity on the person from the earth, and force of the normal person floor. Okay, so let's look and see if we see any pairs yet, right? So we have to look for both the PB. No, because we've got PF, PE. Nobody's a pair yet, right? These guys are not a pair. Same force type, different directions. Three objects again, PEB. That is not a pair. I think there's an eraser on here, isn't there? Let's try it. See how good I am. Ooh, fancy. Okay. All right. So that is not a pair. So we're still looking for the pair. All right. So if I'm going to trace a pair here, okay, these are the two guys that are going to be in the pair, P and B, because this is my feeler dealer pair, PB. Those guys are going to be the ones that are going to have the pair. All right. So on the box, the person is pushing the box this way to the right. So that means that the box has to push the person the other way. Okay. And this is another thing a lot of people were getting confused with on the quiz is you kept wanting it to be what the person was doing, not what he's feeling. So when he's in here, right, he's the feeler. It's what he's feeling, not what he's doing. Okay. This middle letter here is the feeler. This is what's happening to him, not what he's doing. When he's the dealer, when he's the last letter, this is what he's doing. He's pushing the box to the right. He's the dealer. Okay? On this diagram, this is what he's feeling. He's feeling the box push back at him, all right, to the left. Okay, and again, we know if he's not moving or constant speed, whatever, that there has to be a friction. Okay, now let's look at a couple other possibilities. Some people looked at these and thought they were a pair. Okay, they're both equal, yes. Opposite direction, yes. Same force type, yes. But where's the problem? P, F, B. That's three objects. This is not a pair because this is three objects. This is too many guys. PF, BF. No, the floor is dealing both of those. He didn't swap. Okay, that's three objects. That's no. All right. So the only one that we have left is, oops, that's not good, is this one. Okay. Force of the normal on the box from the person. Force of the normal on the person from the box. This is your pair. See how they're labeled? FNPB, FNBP. All right? See that? Same force type, same feeler dealer, but they've just swapped places. Okay? One of them is this way, one of them is this way. That makes them a pair. Okay, so you really need to look at this labeling. We're not just having you guys make all these labels just to waste your time. They're important. You need to look at them. All right, that's how you know it's a feeler-dealer pair. All right, same force type, feeler-dealer swap. Only two objects are involved. It's the same interaction.